Hello everyone. So here we are back again with the next chapter, chapter 9, triangles 2. In this chapter we are mainly focusing on isosceles triangles. So when it comes to triangles based on the sides, we can divide them into three parts. So one of them is where we have the equilateral, and then we have the scalene triangle and the isosceles triangle. And when we talk about the isosceles triangles, the speciality of this triangle is that two sides are equal, and that's a theorem that we're actually going to talk about, where two sides of a triangle are equal. We call it an isosceles triangle. So based on that, the first theorem that we have here is like if two sides are equal in a triangle, the angles opposite the equal sides are equal. All right, so what does that mean? So let's say, for example, we have AB is equal to AC here. So if AB is equal to AC, the angles opposite to AB is angle ACB, and the angle opposite to AC is angle ABC. So which means the angle ABC is equal to angle ACB. So children, when it comes to proving questions, and you see somewhere that they tell you, okay, PQR is an isosceles triangle and PQ is equal to QR, the first thing that you can do is mark that the opposite angles are also equal, because that way you're laying the foundation, or you're laying the base to the problem, right? So this is the first theorem that we have there. Let's move into the next part itself. So yeah, so we have a few examples. Let's look into the examples one by one. Let's look into the questions as well. And in the example here, we have that in the triangle ABC, AC is equal, sorry, AB is equal to AC and ABC is equal to 50 degrees. Find the magnitude of ACB and BAC. Right, so let's mark in the details that they've just given us. And when it comes to this part, they've told that this is 50 degrees. All right, if this is 50 and AB is equal to AC, I know that the opposite angles are equal. So this angle ABC is equal to ACB. So I can mark that this is also 50 degrees. So 50 and 50, ACB is sorted. We've found that that is 50 degrees. And remember, when you're finding angles, remember to put in the reason as well. So you've got to write that AB is equal to AC. Maybe if you don't write the entire thing, but still it's important at least to write this part, that why are you telling that ACB is equal to ABC? Because AB is equal to AC. Now moving into finding BAC. So this brings us to the previous theorem that we've studied, that the sum of the interior angles of a triangle add up to 180 degrees. So basically, which means that 50 plus 50 plus this particular angle BAC should be equal to 180 degrees. So 50 plus 50 is 100, and to make it 180 you need 80 more. So this is the calculation that they've shown. They've worked out the calculation and figured out that BAC is equal to 80 degrees there. So 50 plus 50 is 100, 180 minus 100, which gives you an 80 degrees there. So moving into the next example there, let's see what we have in this question. This is also to find the angle, and they're talking about, let's read the question slowly, and at the same time mark in the details that they've given as well. That's the first thing. Now when it comes to geometry, like 25% of your paper covers geometry. So it's important for you to understand the theorem and read the question. Like if you're getting a question, pretty much the answer is in the question itself. You can find out most of the things by the details that they've given. So what you need to do is read the question, understand it, and mark the data that they've given onto your diagrams. So if you look at this question, they're telling us in the triangle ABC, okay, so which means we have a triangle ABC. Let's look at that triangle here. And they're telling us AB is equal to AC. Okay, AB is equal to AC. That's pretty much marked. So to AC, the opposite side. Now remember, I can't say that, okay, ADC is also opposite to AC. So this is equal to this. We're not referring to the triangle ADC. Instead, we're referring to the triangle ABC. So because of that reason, we have to look at the triangle ABC, and in the triangle ABC, AB is equal to AC. So opposite to AC is the angle ABC, and opposite to AB is the angle ACB. So if this is 40, I can easily mark that this part is also 40 degrees here. So here we go, this is also 40 degrees. And then they're telling us the point D has been marked on the side BC such that, okay, such that AB is equal to BD. All right, we have another side coming in. AB is equal to BD. So this brings us to the sides of the triangle ABD. Now, in the triangle ABD, AB is equal to BD. So I'm going to look at the opposite sides for this. So in the triangle ABD, opposite to AB is ADB, and opposite to BD is angle BAD. So these are the two sides that are equal in this case. Now what do we have to find here? Find separately the magnitude of each of the angles in the triangle ABD. So in the triangle ABD, so we have to find these three angles here. But half of our problem is already solved, like I told you. Once you read the question, put in the data, you're halfway through the solution. Not the problem itself, you're halfway through the solution there. So we've found 40 degrees. We're all good with the first part there. So here we go. Moving into the other two angles that we have to find, that is BAD and ADB. So how would we find that? Once again, we can move to the next theorem, or I mean the previous theorem that we had, that they have to add up to 180 degrees. So to make it a little bit simpler, what I'm going to do is I'm going to mark these two as x and x here. So according to that, it's 40 plus x, which is 2x. So remember, x add x is 2x and not x squared. So 40 plus 2x is equal to 180 based on the theorem that we did, that the sum of the interior angles of a triangle add up to 180 degrees. So 40 plus 2x equals 180. I need to subject x. So remember, when subjecting, that's another major part, like, where many of the students make mistakes, how to subject something. So in this lesson, let's cover that as well. Now I need x alone, right? So the closest to x is 2 and a little bit away from x is 40. So we first remove the further one and then come to the closer one. So first thing I need to do is I need to remove the 40 there. So to remove the 40, 40 is added to 2x. So to remove it, I need to subtract it. Now in this case, you can go with subtracting 40 from both sides, or either doing the, subtracting 40 from 180. That's like doing the opposite there. So I'm going to follow that method there, where we're going to write 2x is equal to 180. We do the opposite. It's added there. So now we bring to this side and say we're subtracting. So 180 minus 40 would be 140 degrees. So now 2x is equal to 140 degrees. But we've not found x yet. We need x alone. So to keep the x alone, 2x means the 2 is multiplied to x. So I need to do the opposite when I'm taking it to the other side. I need to divide 140 by 2. So x is equal to 140 divided by 2. That is, x is equal to 70 degrees. There we go. So let's not forget to put the degrees as well, because it's important to have having the 70 degrees there. And there we go. So our problem is solved. We have ADB, that is 70, and we have BAD, which is also 70 degrees. So yeah, that's about that question as well. On the exercise 9.1, question 1 is for you to identify what are the isosceles triangles and to figure out what would be the sides or angles, pair of equal sides and the angles opposite to that. So that's about the first question. And in the second question, you're going to do, in each of the following triangles, the magnitude of one of the angles is given. Separately, find the magnitudes of the other two angles. So you can mark which sides is equal. So maybe I'll work out one or two questions there just to give you a clear understanding. So let me look at this question. We have, this says 80 degrees. So if this is 80, they've said that AB is equal to AC, which means angle ABC is equal to angle ACB. So if I have to mark, if this is x, this is also x. Okay, so 2x plus 80 is equal to 180, and I'm going to remove the 80. So 180 minus 80 is 100. So if these two angles are equal, and they are equal to 100, the sum of it is equal to 100, basically, which means that one of these angles is 50 and 50. So that's about one of those questions. And in the next example, on the exercise, the question 3, we have a few more questions of finding x, a, y, all the unknown terms that they've denoted there. So if I have to look at one of these questions as well, let me clear the screen. Okay, so let's look at, okay, let's look at the fifth question maybe. So in the fifth question, we need to find F and E. Now, in this part, we are also looking at parallel lines, right? So as soon as we have parallel lines, we can figure out, okay, what are the three angles that come with parallel lines? We have the corresponding, we have the alternate, we have the allied angles. Which angle can I mean, which of them can I apply here and figure out what F and E would be? So if I have to look at this part over here, I can see that they've said that these two sides are equal and this is parallel as well. So if I talk about this 70, what two angles would be equal? And let's see that. Let me mark that here. So if I say that these two sides are equal, I can say that these sides opposite. If this is F, okay, this is also going to be an F there because that's the opposite angle to this particular side. So if this is 70, I can tell that, all right, so F plus 70 is equal to 180. So 2F plus 70 equals 180. So then what can we say is that 2F is equal to 180 minus a 70. So if I'm going to minus 70 from 180, I would have 110. So 2F is equal to 110. And we can say F is equal to 110 divided by 2, which is equal, which is equal to 55 degrees. So there we go. Part of our problem has been solved. We have F equals 55. Now let's move into how would we find E in that case. So we have an E at this point here. And how would we figure out which angle is equal to what? So let's mark in the data once again. So if this is E, I can tell like, okay, this is equal. These two angles are equal. So if this is E, I know that this would also be E here. Okay, so this is E, this is 70, and this is 55 that we figured out. So let's look at this. Let me just quickly clear the screen to give a better understanding around alternate angles as well. So if you look at this part here, we have an alternate angle that is being formed. There we go. So this is an alternate angle that has been formed. So if this is F, we know that this is also going to be an F based on the alternate angle theorem. So if 70 plus F, and we already marked that this is going to be E, let me just make it a little bit clear. So this is going to be F, and this is going to be E. So if I have to mark these data, it's angles on a straight line. So angles on a straight line, 70 plus F, which was 55, plus and E is equal to 180, right? So now the next part that comes in. Now when I talk about this method, this is not the only method that you can solve. Let's not forget that as well. This is not the only method. You can use multiple other methods as well to figure out the answer, right? So if I have to add 70 plus 55, so 7 add 5 and 0 add 5 is 5, and now we've got to add 7 add 5, so 8, 9, 10, 11, 12. So we have 125 plus and E equals 180, and E is equal to 180 minus 125. So another easy trick that you can use to multiply this is you can count on. You can look at, okay, 125 to 130 is like 5. So 130 to 180, 140, 150, 160, 170, and 180, that's 50. So once again, E is equal to 55 degrees. Okay, so how did we get that E is also equal to 55 degrees? What's happening here, right? So the other thing that you can apply at this point is, well, even without working out this entire thing, you can find it out using corresponding angles. Okay, so now what's corresponding angles and how do we apply that? So if I have to look at this part over here, let me just change the color once again. It's not the text, the pencil, and the color goes to green. So if you look at this part, we have, here we go, the corresponding, which has to form an F, and this is the F that we have right now. Here we go, this is the F. So if you look at the F, the angles under the arms of this big one is this, and the angle under this arm is this. We already know that this is F. So we can say that F is actually equal to E. So we can use this shortcut method and say F is equal to E, therefore it is also equal to 55 degrees even without working out this entire thing. So like I told you, now in maths we have a lot of methods that we can use. We can use the simpler one or the longer one, choice is ours. So it's best if you can figure out the shortest method because that will save time. We know how much of how precious time is while you're working out your maths paper. So that's exactly we need to figure out, okay, what's the shortcut methods and how can I figure out the answer at that point. So there we go. That's pretty much how you will work out this particular question. And I'll clear my screen once again. Let's move into the next part. So we have a few more questions where they're talking about uh, a few finding magnitudes of different types of angles there. And now we're moving into the formal proof of this theorem. So what is the formal proof and how are we going to apply this theorem? Now to prove how we say that, okay, these two angles are equal, we're going to go with congruency. We did cover congruency in chapter 5. So under congruency, we said that if two triangles are met with with these two, with four conditions, side, 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 side angle, angle, side, and right angled hypotenuse side. These are the four cases that we did study under congruency. So if we can prove two triangles are congruent, we need these four cases. Any of the four cases would be all right. So if I have to prove that part here, now looking at this particular triangle, they have the data, they have the proof that they have a construction, and finally they have the proof there. So the data says that, okay, AB and AC, they're equal in the triangle ABC. You've got to prove that ABC is equal to ACB. All right. And then as a form of a construction, what are they doing? They're drawing the bisector AD of the interior angle BAC. Remember, when we say bisector, we are dividing the angle BAC equally into two parts such that it meets BC at D. So there we go, we are done with that. Now we have that this angle is equal to this angle here, that is BAD is equal to angle DAC, and AB is equal to AC. So basically we have one side and we have one angle. Side equals, AB equals AC and BAD equals DAC. So side and angle done. Now either we've got to find another side that is equal to go with side angle side, or we have to find another angle to show that they're congruent under angle side. But it's pretty much obvious that we have like AD, we have a common side to both. So we can go with side angle side and say that these two triangles are congruent. All right, we've proved that they're congruent, but have we still come to the main motive? Not yet. So what was the main thing that we needed to prove? That ABC is equal to ACB there. So to do that, we can move with, after congruency, we always said that the corresponding elements of congruent triangles are equal, which means the corresponding angle ABC is equal to the corresponding side, which is ACD. So that's the main part that we have to remember. That's how we prove that these two angles are equal using this is the formal proof of this theorem. And I hope so far it has been clear with what we've done. Let's move into some of the other examples that we have, and we'll move into the questions as well, and then we have the converse of the theorem coming in. Yeah. So let's take an example 1. Now in this particular, let me clear the screen, there we go. AB equals AC, the triangle ABC in the figure, show that the following coincide. Okay, now what does that mean? The perpendicular drawn from A to BC. So this is another thing that we are proving actually through this example here. So what are we going to prove? That the perpendicular drawn from the apex to the opposite side, the bisector of the apex angle, the straight line joining the apex to the midpoint of the opposite side, and the perpendicular bisector of the side opposite the apex coincide with each other. All right, what did we read just now? Quite complicated, isn't it? No, it's not really complicated, but what are they saying? That the perpendicular drawn from the apex to the opposite side. So this is the perpendicular drawn from the apex to the opposite side. Okay. The second one, the bisector of the apex angle. Okay, the bisector of the apex angle. That's the same thing. The straight line joining the apex to the midpoint of the opposite side. Okay, the straight line joining the apex. This is the straight line that's joining the apex to the midpoint of the opposite side. Basically, this D is the midpoint of BC. and the perpendicular bisector of the side opposite the apex. So what are they talking about at this point? The perpendicular bisector of the side opposite the apex is these two parts here, BD and DC. They are all going to coincide. So think of it this way. You're going to fold this ABC triangle from AD. What happens? This is actually the symmetrical line there, which is they're going to coincide. They're going to be one on top of the other, right? That's exactly what they're trying to show here. And they're going to prove that using congruency. So congruency says, like, if you look at this triangle, AB is equal to AC, data given. Angle ADB equals angle ADC. So angle ADB is equal to angle ADC, and that's equal to 90 degrees because that was one of the constructions that we did there. And on top of that, we know that AD is a common side. So they're proving that ABD is congruent to ACD based on RHS, right-angled hypotenuse side. So because of that, we can say since the corresponding elements of congruent triangles are equal, we can say that BAD is equal to CAD. That's equal there. So we've proved that the perpendicular drawn from A to BC, and I mean they coincide. That's what we need to prove, right? So we've shown one part of that. And that brings us to the next part, that AD is the bisector of BAC, that AD bisects the angle BAC equally into two parts. And BD is equal to DC also, like I told you, because again, corresponding elements of congruent triangles, and therefore AD is the line joining A and the midpoint of BC. So the last part that they've spoken about is ADB equals ADC equals 90 degrees, also BD is equal to DC. Therefore, it's the perpendicular bisector. It's not just the bisector of angle BAC, but rather a perpendicular bisector which has a 90 degrees there. So that's what they've proved there and worked out the question. Let's move into this example 3 to show how we can work out proving questions. Remember, whenever you have the proving questions, don't forget the data to prove that and the proof, because that's a way of writing the answer, and that will definitely give you a good score as well. So ABC equals, in the triangle ABC, they're telling us that AB equals AC. The points P and Q lie on the sides BC such that BP equals CQ. All right, let's mark the data once again. We know that AB is equal to AC, so we're talking about triangle ABC. So this angle is equal to this angle here. I'm done with the first part. And then they're telling us BP is equal to CQ. Okay, that's already marked, so I'm not going to go into details there. Prove that triangle APB is congruent to triangle AQC. Triangle ABP or APB is equal to, congruent to triangle AQC. I think we've pretty much have all the data marked, and it's quite clear. We have side, we have angle, and we have a side. So they're going to be congruent under side, angle, side. And after that, they're telling us to prove that angle APQ, okay, we are referring to not APB, but APQ, okay, this angle is equal to angle AQP. These two angles are equal. All right, that's interesting. So now we have two ways actually where we can work this out, but I'll show you one of them there in this case. One thing that we can say is, okay, AP is equal to AQ. Why? Corresponding elements of congruent triangles. We already proved that ABP is congruent to a triangle AQC. So we can say that these two sides are equal. So if these two sides are equal, we can say that these angles are also equal. So that's how we can prove. That's the simplest method that you can use to prove that these two angles are equal in this case. All right, so I hope that part was clear as well. Let's move into the exercise. So exercise 9.2, we have really some interesting questions. You can definitely work them out and see how the questions are different from one another as well, right? So let's look at one of them. In the given figure, ABC is a straight line. Provide answers based on the information in the figure. So they want us to find the value of BAE plus BCD. And then they want us to show that TBE is equal to 90 degrees. All right, interesting. Let's see what we can do in this case. So here we go. I guess I'll zoom in a little bit. Okay. So now we have the diagrams clearly there. Let's mark. Okay, these are the two opposite sides that are equal. And if this is X, this would be X. So I'm going to mark that as X. And if in this triangle BCD, if these two sides are equal, opposite to this is this angle. So if this is Y, this angle is also going to be a Y. All right, problem solved. Not yet. So we need to find out the value of BAE plus BCD. That is, we need to find the value of this, this BAE and BCD, these two. All right. I think before we move into the question, to this particular question, it's that it's equal to 180 degrees. If anyone can remember, we are using these are parallel lines. AE is parallel to CD. We have allied angles, which says it forms like a U or C, whatever you can call it, that if it's this way, these two angles, they add up to 180. They're not equal. Remember, they're not equal, but they add up to 180 degrees. So we can say that this is equal to 180 degrees. Next, we talk about finding DBE. All right, so how am I going to find DBE? So these two angles are equal to 180, and we need to figure out what this angle is, DBE. That is here. So to do that, we can actually figure out, okay, what is x plus y? That's exactly what we need to figure out in this case. So how would I figure out what is x plus y? I have a lot of data, but I need to pick the ones that I really need, right? So if you look at this part, you can tell that this is 180 minus 2x, because interior angles of a triangle add up to 180, and this is 2x, so 2x plus something gives you 180. So basically 180 minus 2x gives you BAE. So I'm just going to write that down, that BAE is equal to 180 minus 2x. Okay. And at the same time, using the same method, I can say that BCD is equal to 180 minus 2y. So now let's see 180 minus 2x, 180 minus 2y. But we already showed that BAE plus BCD is equal to 180. So BAE plus BCD is equal to 180. So I'm going to replace, so put 180 minus 2x plus 180 minus 2y. And that's also again equal to 180. All right, so we have a lot of 180s, and what are we doing here? So 180, add 180 would be again 360 on this side. And I bring the number 180 from the other side to this side as well. 360 minus 180 equals, now minus 2x and minus 2y, they go to the other side as plus 2x plus 2y. All right, so 360 minus 180 would give me 180. This equals 2x plus 2y. But my problem is not solved. I need to figure out what x plus y is. So I can divide the entire thing by 2, which would give me 90 equals x plus y. So now let's see if 90, x plus y is equal to 90. Basically, this plus this is equal to 90 degrees. We can say that this is also equal to 90 degrees. So the reason behind that is angles on a straight line, they add up to 180 degrees. That's why we say that this is 90 degrees. So that way you can show that DBE is equal to 90 degrees. So I hope that example, that question there was also clear for you to work it out. Let's move into the next part then. That's the converse of the theorem of the isosceles triangle. So we have a little bit more to cover, and then we're done with this chapter there. So what is the converse of a theorem? Whenever we learn a theorem, we always move to the converse of it. That says the sides opposite equal angles of a triangle are equal. All right. So if we are given that two angles are equal, let's remember that the opposite sides are going to be equal. So in this case, PR is going to be equal to PQ. So let's move into some examples to work it out. So they're telling us find the equal sides of the triangle. All right, so we need to find the equal sides. We have 80 and 50. So we need to figure out what this would be. So that would be 50, because angles in a triangle should add up to 180. So 50 plus 50, 100, 100 plus 80, 180. So these are the two angles that are equal, but they're saying equal sides. Find the equal sides. So opposite to 50 degrees here is BC. Opposite to this 50 degrees here is AC. So BC is equal to AC. And let's clear the screen before we move. Based on the information in the figure, show that AC is equal to AD. This is pretty much the same question that we had previously. We can do this also in different methods. We can apply the exterior angle theorem, that ACD, we can find ACD, that is 60 plus 25. Exterior angle is equal to the sum of the interior opposite, sum of the interior opposite angles. So these are the two interior opposite angles. 60 plus 25 is equal to 85. And if you look at this part, we can find using the straight line theorem that 180 minus 95, that's equal to 85 as well. So these two angles are equal. So if two angles are equal, that means the opposite sides are equal. So AC is equal to AD. So that's another method that we can apply to prove that these two are equal. So moving into exercise 9.3. In this question also we have different types of, first part which says selecting the isosceles triangles, and then we have proving that this is an equilateral triangle, and let me maybe pick one question there so that we can work it out together. And yeah, let's go with the third question. So AB is equal to AC in the given triangle. The bisectors of the angles ABC and ACB meet at O. Prove that BOC is an isosceles triangle. We need to prove that BOC is an isosceles triangle. So how am I going to do that? So as soon as you see that these two sides are equal, I can mark ABC equals ACB. And they're telling us the bisectors. Okay, that gives us like half my problem is solved. Bisectors. What does bisectors mean? That if this is X, this is going to be X. And if this is Y, this is going to be Y. So which means 2x is equal to 2y. So if they are equal, basically x is equal to y. So if x is equal to y, I can say that OB is equal to OC, and that makes the triangle BOC an isosceles triangle. So that's pretty much it with this chapter, and like we've covered most of the things. You can go through the exercises, go through the questions and work out a few questions. And if you don't understand something, like you can drop me an email, or you can comment, or you can go ahead with the comments as well, and I'll be glad to help you out there. So thank you very much for joining in. Have a nice day. Bye.